Welcome everyone to real IT news, exceptionally no security stuff today, but latest and greatest breaking news of Nvidia announcing a CPU core for giant AI. Obviously everything is AI these days, and high performance computing workloads. But hold your breath, of course, the internet is full of that is the end of x86 and Intel and AMD. But not so fast, because this is only an announcement of a processor not only for HPC, high performance computing, there in data centers of in Switzerland and US Department of Energy, Los Alamos National Laboratory, and even that is many years in advance. So what this is a 10 times performance leap for systems training giant AI modules. Energy efficient ARM, of course, CPUs, as Nvidia currently tries to buy their pending, pending approval. But so that is a more than 10,000 result of 10,000 engineering years of work. Nvidia's Grace TM CPU, and as I said, this is many years in to come. I think it's like targeting 2023 and not even coming to your living room for playing along at home. First adopters push Enterprise Online 2023, CSCS and Los Alamos National Laboratory. Both plan to bring Grace-powered supercomputers built by Hewlett-Packard Enterprise Online. So that could be delayed in any way. It's not for your living room. Of course, this just underlines how serious Nvidia is with their business, but what regulators' approval pending there might bring. Anyway, even if in the end Nvidia is not allowed to take over ARM, which probably would potentially be better for the ARM industry and ecosystem, Nvidia of course could still bring license that. Certainly they probably have a license. Lost overview of all the many ARM licensees. Anyway, of course, AI learning and LPDDR5X memory and so on. But again, this is also still quite some years ahead. Availability expected in the beginning of 2023. In similar amazing news for playing along at home and CPU processors for your living room, Intel's 11th gen Core S series desktop, core named Rocket Lake S, released some week ago. It was so pathetic and unnewsworthy that I didn't feel like making a dedicated news shout out. You probably have seen summarized on other YouTubers, but I just want to quickly recap that. It's of course the plus improved and backported process. Backported, that means Intel had of course new architectural designs in the making with 10,000 of engineer hours, but their silicon process, lithography process, of course, everyone knows, delayed by years and years and years, so that they had to backport some, meaning like similar to software. You have your new next gen, latest and greatest design. You just can't manufacture it, so you backport similar to software libraries and code like the Linux kernel, some bug fix from latest and greatest security vulnerability, backporting that from 5.11 to 5.10 and stuff. So just taking some, like cherry picking some bits and pieces of our previous videos here, designing stuff with logic gates and Verilog here on FPGA. Just whatever they can fit in there. And of course, the result is faster. Obviously, would be very sad if it wouldn't be, but not by very much, as seen here by other YouTubers. And of course, for Intel latest and greatest architecture in years of making and backporting, the result is obviously somewhat disappointing, if not others call it pathetic. And if you take here the latest and greatest flagship SKU of 1100K with 8 cores and 16 threads here in some, but this is similar to other benchmarks. Obviously, you probably have seen this already. But long story short, other SKUs from AMD here of what we are rocking ourselves with partially burnt memory channels in the previous video, overtakes that easily in most benchmarks, and even pathetically due to architectural backports of more reorder buffers, instruction units, and so on, taking more silicon die space. I think the oops, that is the next use. I think the die is some 20% or so larger, and this also makes a very pathetic situation here that previously the flagship SKU of Intel i9-10900K had 10 cores and 20 threads, and this year's Rocket Lake Intel i9-11900K has only 9. Most likely, obviously, pure limit of how many cores they can squeeze into the die, and other people, I think, had their Bauer, I think, decapped that the die is of course massive and they just couldn't fit in more cores, and many other reviewers, including Gamers Nexus and so on, called out that, or even maybe even der Bauer, but probably most of them called out that it's very pathetic and strangely misleading, but that is not a new thing to this kind of hardware vendors, that even AMD did before and even today with 5000 series of in the mobile part, even AMD slipping in previous gen silicon with very confusing naming schemes, previous video. But yeah, super misleading in my opinion, or most others' opinion, that 11th gen 900K has 2 cores less. That certainly explains this. Yes, this 11th gen is similar to Zen and stuff, 18-20% faster compared generation to generation. But with 2 cores less, it's no surprise that depending on the workload, the previous gen, 10th gen 900K can overtake this. Of course, in games, you might wonder why is Intel doing such stuff. Well, they have not much other choice, and to their credit, in some games, not as massively multi-threaded as our open source T2 compilation or Blender rendering here, not as embarrassingly parallel. So for some games with single or few core load, the new 11 gen 900K can make sense and doesn't look as bad as it does in this, but yeah. So for gaming, sure, can make sense. If you do other stuff, programming, other 3D statistical workload, and all the other content creation or gaming and streaming or whatever, your take might be at home. AMD or even the previous gen might be preferable. Of course, there are some other benefits, including PCIe 4, I think, was it that product brief, or these marketing slides are a little bit near. Oh wow, I should have changed the contrast. But anyway, this is, I think, not the marketing slide I was looking for. Maybe this one. Maybe also not, but let's see, do we have this in PCI? Whatever, something. Man, which of those was this even? This one, but I'm also not so very, I think it was actually this slide, just that it wasn't in the right slide. Yeah, I mean, yeah, 19% similar to Zen 3, 18% or so, plus IPC plus caches buffers. Of course, 2021, Intel's biggest marketing number, 50% better integrated graphic performance if you happen to run an integrated graphic SKU. And yeah, here's the new stuff, IPC, enhanced UHD 20, PCIe 4 lanes, so that is new. Otherwise, deep learning boost, VNNI support, enhanced media compression, and support resizable. Of course, totally, I would think this is total misleading point. This, of course, could be supported in previous. This is simply a PCIe and GPU feature. I would think this, in my opinion, but correct me if I'm wrong or don't quote me on that, but I would think that previously that should have worked with an OS poking the PCIe registers or the BIOS already initializing that. So this is just a vaporware of no, this is like kind of AMD Novi supported officially, but you find mileage may vary. So some massive performance of 13-14% massive massive performance. Anyway, in more amazing news, SiFive tapes out RISC-V silicon and 5 nanometer TSMC process of 5 nanometer, obviously smaller than what Intel currently has to offer. I should say that Intel also, in other news, I could mention that with 2 sentences, plan to massively invest in their fabs here somewhere, even in the US, making US fabs great again. And certainly that is very much needed if Intel wants to stay competitive, because certainly their plus process doesn't cut it very much anymore. So, all right, and one last note, of course, this Intel CPU certainly they anyway will sell, simply because the supply and demand, as seen here, I can't even source a freaking hard drive without getting non-genuine for resale stuff or otherwise broken stuff, let alone a GPU. So of course this stuff will sell simply because availability. Intel's only benefit of, they have their own fabs, they are a plus process, but hey, at least they are not overbooked and over 100% capacity as TSMC is. So the stuff will sell. It will not be such a cash cow as stuff was previously for Intel, simply because not the performance leader, and the die is 20% larger or so, and due to not being the performance leader, Intel can't gross in as high profit margins as they could before. So good for Intel, it will sell. Bad for customers that it's not as fast as some non-plus process could be, but at least customers can buy something. In this RISC-V news, SiFive Business announced here the tape out of a Open 5 RISC-V processor, SiFive 7 series IP on 2.5D based SoCs. And the thing is, of course, I have this similar to Nvidia news. This is nothing for you playing along at home soon. Probably takes over a year to see this somewhere in production. I have this SiFive Unmatched on pre-order since December. It was delayed. Hey, at least they bumped the memory from 8 to 16 gigs there. But this is currently also, why does this load so, oh wow, massive, shit, we had much frame drop. Should have had an eye on that, but that's what you get from failing doxes. Here. This SiFive Unmatched, and even that performance is of course not state-of-the-art Zen 3 or Intel 11th gen. This is of course a small startup doing this stuff mostly new from scratch, and RISC-V is not the limiting factor. The limiting factor is designing all the massive out of order, speculative, and so on, massive reorder buffers, and so on features there for the first time. And this board unfortunately delayed, and so I hope I get it in June for our RISC-V fun here on this channel. So as with Nvidia, so nice to see, but TSMC does not have much free manufacturing capacity anyway, and tape out does not mean they must produce that. Now, anyway, nice to see this stuff is moving on. Various features, HBM3 IP. Do they have other? Of course, they don't have that many mixed either. What do they even say? The ARM core inside. What the heck? Uniquely, SiFive inside is compatible with ARM's core side. Interesting. But that's probably only some design environment or something. Addressing security needs, of course, a lot of the stuff is like regular security over military grade security or stuff. So just a regular update of processor portfolio of the Relentless Innovation Program. And that is certainly nice to see. Of course, it's not like fully open source. A lot of people always confuse this. This is, of course, a for-profit and not 100% open hardware company. But at least the ISA is open source. Previous videos we went through their RISC-V ISA. Huge fan of that for the most part. And of course, they don't even write here so much. They write here the usual vaporware stuff of enabling more choice. If they can manufacture and have them like more choice, as in choice between Nvidia and AMD GPU availability. A lot of choice. Next generation AI powered products, 5G automation, data center, edge, high performance computing. The usual is like just put all buzzwords in there and hope something sticks and sells. But this also brings me to, in general, of course, it will be a couple of more years, maybe even at least a decade until, unless Intel and AMD bring slap a RISC-V decoding front into the embarrassingly massive parallel brute force computing ISAs there. But unless that happens, doing that by small companies, new startups like this, it's for sure a decade until we see true high performance state-of-the-art desktop server HPC stuff, similar to what Nvidia, Intel announces there, and of course AMD has there on the market. So nothing epic thread-ripping yet, but anyway, that's similar to the Linux kernel. It started small and eventually got bigger. I wonder if we will see the day where Intel and AMD release actual RISC-V based ISAs. Because obviously, as seen in previous discussions here, and Apple's M1 or other A12 and Apple Silicon, what I always said here, x86 is way too complex to implement embarrassingly massive parallel as required for Moore's law to yield performance increases as seen in Apple's M1. I also wonder, due to the nature of previous videos, ARM being so much more streamlined, much easier decoder. And yes, decoder, yes, I am fully aware it's a totally tiny little small part, but the thing is, x86 is variable length encoding from 1 byte to I think 16, and ARM RISC-V and stuff usually either 4 bytes, 1 word per instruction, or compressed encodings of RISC-V 2 bytes, 2, 4, or stuff like that. And that just makes, on the ARM and RISC or most other RISC instructions and architectures, the encoding front end way simpler. Imagine implementing that in pure logic of decoding 1 to 16 bytes and then doing that in parallel. I think the Apple M1 was it 8 byte issue or something, and Intel and AMD like 5 or 6 or something, and that are industry high performance desktop leaders and Apple's latest and greatest energy efficient ARM stuff. So there are certainly limits and how much you can chain variable length encoding in hardware in an n-byte instruction set decoder n-byte issue there. This is mostly the summary. I have also to say, I was looking into this, what kind of reviews. Certainly for me it makes no sense to also get into the business of getting an Intel CPU and performance benchmarking that. There are certainly many YouTubers who are specialized in this. There's not really something I could contribute to that, to otherwise excellent reviews of people like Gamers Nexus. Did I close this even? Here. Gamers Nexus or Der Bauer or other such reviewers. Can only point you to that. I can probably better provide some developer perspective. And as a developer perspective, was not only the Intel 11th gen is pathetic and otherwise than ARM RISC-V. For me, I have to say, unlike people trapped in the Windows ecosystem who only can support x86 or maybe potentially ARM, we can of course support everything, and I certainly do that for a decade with our open source. Just massively parallel cross-compile that from alpha ARM RISC-V stuff. So for me it's like writing portable hopefully not C, at least C++, Rust, Swift stuff, just compile it with GCC or Clang and call it a day. So for me, I don't even care whether it's ARM, RISC-V or x86. Just give me something performant. And last but not least, I'm also, I would say, like, considering the possibility here of writing a whole new, like, more innovative microkernel operating system from scratch, or just using Google's Fuchsia or something. But the more and more I look into this, of course, one thing that stops me a little bit is the sheer complexity of x86 with it's not dozens, but probably multiple dozens of architectural extensions. Not only all the legacy stuff that you of course don't need to use, but even vector extensions and then other security extensions and stuff. Of course now matrix extension and other stuff coming. But the thing is, even promising security from a otherwise secure microkernels, even who knows what strange processor feature you've forgotten and you can accidentally trigger from user space of all the stuff they put in there. And from my perspective, I would rather prefer less complex instruction set architectures like RISC-V, but also not only RISC-V or ARM, but also other hidden features surrounding hardware virtualization. You know, the problem is a lot of news always just praises new features of encryption and this and that, but you also need to support this in software. And of course, that also makes data center compute stacks, the Linux kernel, also fragile and security-wise. Someone needs to test all this stuff. I think through this, there are always bits and combinations overlooked these days, similar to USB and stuff, because the standards are just 1,000 pages long, and there are edge cases or even standards not written or not formally verified, similar to Intel extensions. How many erratas are there for don't use it in these combinations of don't enable this feature, or Spectre and Meltdown. So as a software engineer or thinking security forward, I would rather prefer much simpler architecture with less exotic hidden features there for whatever case might be, like think SGX and other TSX. I mean, who is even using all the stuff, Secure Enclave and other transactional extensions? There's so much stuff in x86. When I scroll over the summary already, I was like, I really want to write an operating system kernel. It's like, yeah, maybe just use Linux or otherwise. Anyway, we will continue to report the stuff, also write example code for other bits and pieces. Here, let's take a quick look at the comments. Welcome everyone there. The Graver points out XORG security vulnerability. Yes, I've seen that. Thanks for that. We probably can go and update that. And otherwise, Jim writes, someone once pointed out that AMD drivers were not stable enough for use in non-gaming workloads, especially Linux. What you experience with this? Well, with the AMD drivers, well, I'm rocking his totally old AMD Radeon because I actually wanted to get an RDNA 2 card. I didn't expect that with the pandemic we have no stock and no, well, I'm certainly not overspending like double or triple that to just have a GPU. I have zero issues. I have only issues with now AMD Ryzen USB after the BIOS that should have solved USB issues caused some for me. Otherwise, I had some issues of undervolting and performance boosting a little bit on the edge of hardware stability, but otherwise USB. I don't have an RDNA 2 card. I'm super happy with open source drivers. Maybe, well, Windows drivers may be subject to instabilities. That's why I don't use Windows since 1996-ish. The open source drivers are perfect for me and nothing much to complain except potentially having them in a multi-server microkernel. So in general, I would actually not mess with Nvidia binary-only driver. So from my side, I want a stable, maintainable, and independent developer, reviewable and fixable system. So for me, the Intel and AMD open source graphic drivers are the only way to go. I don't quite understand why people want to taint their pristine, pure open source Linux or BSD kernels with some Nvidia blob that you then have issues with. At least as a desktop, on the compute servers it might be different, but on the desktops, like, doesn't work with Wayland, with hardware acceleration, with this, and then it's like, yeah. I personally never, let me think. I think in my whole life I never purchased a retail Nvidia GPU, except one for my brother, so only indirectly, but that was a Riva TNT2, and otherwise only indirectly through Apple MacBooks and Apple G5, and of course a Sony PS3. So yeah, and that certainly headaches of the last person who tries to support the PS3, so previous video and other such stuff. As usual, leave me in the comments below what you think. What generation of CPU are you rocking? Last update, I still have not approved RMA here. The last email from AMD yesterday morning was because I had to send I burned, for those who are new to this channel, I burned with the BIOS update, burned the memory channel A of my €999 AMD Ryzen 5950X. That's how BIOS quality, random BIOS quality in 2021. Latest update from AMD, help desk system. Thanks for your email, but it didn't include attachment. I checked my sent email. Of course, my sent email included attachment of a photo and PDF, so resend that differently. It's like 2021 help desk systems remove inline PDF and images. So still hoping for the best there. So the RMA process, certainly I understand to some degree why some people want Apple for the integrated experience. Although on the other hand, I would not had to update the BIOS. The system was perfect, recurring theme, never touch a running system, especially not BIOS updates if you are otherwise happy with it. Hans says, hope Intel starts to support VFIO for the graphic card, so you can use it in a VM and host. Well, Intel has done this, pioneered that for a long time. One of the few things to applaud Intel for with this vGPU stuff. I tried that personally already many years ago, before it was cool, maybe 2 or 3 years ago. Barley worked back in the day. Ironically, I tried this maybe on Haswell, and a little bit annoying, they removed Haswell support there. Not that it would be that important, but always a little bit. Once upon a time there was code, and then it's like, nah, nobody's gonna maintain that, let's delete that one. But yeah, I wish AMD would support that. I'm not sure what AMD support there on that front. I think open source not, but I wish they would maybe. Yeah, but it's open source, so nothing stops you and me to theoretically do that there. But yeah, Saturdays equals use. Not sure if you talked about already about what you think about framework laptop. Didn't look too much into that, but it's probably often too much outdated hardware for too much wasting space for modular. I'm never looked into the swap, or I was never looking for or asking for this swappable module kind of thing. Just give me a properly repairable laptop with non-glued battery, and you can open it with a normal screwdriver. So from that part, a Lenovo ThinkPad, previous videos, pretty fine for me. The only thing is, of course, BIOS, right? Of course, on some decade-old stuff, you can run core boot so now, but that is for me, as much as this binary blob BIOSes burned me personally the last days here, or actually the last 6 months or so, I would seriously question more. I mean, before I was not the greatest fan of previous 16-bit remote PC BIOSes were complete garbage. Then the EFI complexity that at the beginning was also lackluster. Nowadays, of course, relatively mature, but mature if you're not going to the BIOS settings and try to change this random stuff of. But I would want now, after this disaster of AMD, AGESA and ASUS, probably all vendors BIOS binary blob garbage. I would actually even more want an open source BIOS for knowing what the bloody BIOS does. And yeah. Sebastio asks, sorry if I mispronounced that, but would it be worse Intel adopted RISC-V? Yeah, that would be totally amazing. I don't see, and this would also probably solve Intel's x86 scalability problem. I don't see Apple doing that though, because they just earn, they would lose their leverage of vendor lock-in. Right now you have only Intel versus AMD if you're not wanting to run yesterdecades via nano stuff or other such stuff. So from Intel's point of view, it of course makes business sense of locking in people into the x86 patented non-open instruction set architecture as long as humanly possible. So it would make sense for the future of computing and even potentially could increase their performance. The only thing is, of course, vector extensions that would need major rework of maybe using RISC-V vector extension in contrast to AVX 512 and stuff, would have a lot of nice benefits for the industry and scalability in the long term, but of course would not help Intel in the short term. Plus a lot of people buy x86 Intel for the Windows vendor lock-in. That is still the desktop, predominant desktop thing there, unfortunately, because the year of the desktop Linux has not yet really come. Let's see. Anduin writes, getting 3990X in July, that sounds amazing. I really hope the hardware availability improves, because I run a entry-level test. I don't often need that much, except YouTube and other AI and fun stuff, but it's certainly, somewhat limiting on the hardware front here. All the YouTube video review and software stuff. Gregan asks, what do you think the next x86 Meteor Lake brings to us? I think the performance will not be the most visible. It will be another 18% step, unless you pair this with DDR5 memory. Of course, DDR5, which probably the next generations will eventually bring, this will massively boost memory bandwidth. It will, of course, mostly, so gaming will probably not even get much faster with DDR5, only embarrassingly massive parallel workloads like render, video, like 3D render, video render, AI, other number crunching, statistical stuff, software development, compilation. Only such kind of stuff will profit. This is also why in 3950X, 1550X with 16 cores, 32 threads, you need dual channel memory and fast timings and stuff on the AMD Ryzen side, because just so many embarrassingly parallel cores, even with in total 72 megabyte of caches on the 59 and 3950X, massive amounts of caches, way more than my first PC had even memory. But eventually you hit memory, and the more cores and threads, the more memory bandwidth of course you need. And of course you only need and see that in such massive parallel workloads. Otherwise, yeah, I think even AMD will most likely, I mean, I don't see any magic breakthroughs, just because x86 is so convoluted. More than some 18-ish% like AMD and Intel recently pulled off, I don't expect there from any of those. And probably only due to the sheer complexity and legacy crap, it only becomes harder and harder. Maybe it would be possible to revamp, and maybe you heard that here first, maybe that is the first, not sure if anyone ever said this, but looking from that, my first thought as a computer scientist is maybe massively cut away legacy stuff like real mode, also like old XT, like 8086-ish, like 286, even 386, maybe even like ARM. Even there are some like Apple or other HPC ARM CPUs that even don't support 32-bit anymore. Maybe if you make future Intel CPUs, but nobody ever talked about this, right? Maybe this is the first, and maybe I want to share, like, and subscribe for this. So maybe, of course, x86 still stays very complex and variable length instruction set, but maybe dropping this legacy stuff, because who boots MS-DOS or PTS-DOS or FreeDOS on their epic thread-ripping AMD Ryzen or Intel Core i11? Certainly nobody or runs Windows 3 or OS 2 or whatever, and makes this, delete that. It of course does not improve much, so maybe this is only like 1-2% of logic, or maybe even less, but everything counts, right? And then maybe make this, maybe define a new, but that's not so easy, right? The problem is always running over legacy hardware. The problem is if you simplify the instruction architecture, like the variable length encoding, to improve timings in that, to reach higher IPCs and clocks. Not sure how much that would gain, but certainly deleting some remote stuff could improve timings a bit. Unfortunately, Intel made themselves a trap with SSE and AVX stuff that's massively logic gate wasting. Previous video agreeing there. Once upon a time with Linus Torvalds, hopefully AVX 512 will die a slow or fast death, because all the logic wasted of even limiting turbo boost frequencies for stuff you rarely use, and if you use it, it massively slows down your performance boosting clocks. But they're similar to, as seen previously, RISC-V vector extensions of something more automatically scaling, of not specifically targeting SSE, AVX, AVX2, AVX 512, but having that scaling with some flexible vector extension as seen in RISC-V, and I think recently also adopted by ARM's, what is it, vector extension 2 or so, or something of that sort. I think scalable vector, and maybe SVE, scalable vector extension 2 or something on the ARM side. That could help also forward performance compatibility. But the problem is, again, Apple is trapped in their x86 vendor lock-in, and removing a lot of this legacy ISA stuff would render the benefits moot. Realistically, the only stuff I see is remote garbage, and maybe even non-64-bit long mode stuff of, yeah, maybe that would help a little bit. And the biggest would, of course, if the x86 variable length stuff could be a little bit less variable, to make it significantly easier, or even latency and signal propagation, latency timing wise, viable to implement a more wide instruction decoder of similar of Apple's M1 of 810 issue, but as it is right now, I don't see that. So yeah, but some stuff is certainly possible to get rid of there. Saturday's equal use rights wants an open source BIOS too desperately. Yeah, I mean, there are open source BIOSes, right? There is CBIOS of QEMU stuff. There is the Intel reference EFI BIOS, and there is Core Boot. But the problem is all the hardware complexity, right? This is also what I previously meant, but this video is, again, as usual, getting too long. Digressing here in details surrounding that. And oh man, drops frames. Yeah, you can't rely on Vodafone's failing DOCSIS cable infrastructure, because 5.9% drop frames of 4,300. with where was I with hardware features. The problem is also ND8 and intellectual property. Always this intellectual property bullshit of we can't disclose memory controller register bits and stuff of DDR4, DDR5 training and such bullshits, because that is of course what also already is such a mental barrier for me to continue with x86 operating system bare metal stuff, because oh my god, the sheer complexity of all these bits and pieces. But this is the thing, right? It's not a open source people cannot do it. It's just the stuff is so ND8 intellectual property and so on, reverse engineering, time consuming, that it's simply, it needs a vendor effort. And unfortunately the big proprietary American megatrends and Phoenix and Inside BIOS vendors have zero interest of losing their business, and the Intel and AMD are somewhere with their work relations. They're so trapped mentally that somehow they are not willing to innovate, unfortunately, in this field at all, because it also works for them, right? With binary blob closed BIOS and Windows, that's what 90% of the customers are using, and so yeah, there is not really market pressure and for them to change that at all, unfortunately. Yeah, anyway, reduce UEFI complexity with a new revision. I'm not sure, usually only new revisions only make it more complex, so I'm not sure if a new revision would make it less complex. Usually they only add and slap on more and more features, unless I missed something and there is a very specific feature reduced version of that. But yeah, leave me in the comments below, maybe I should take a look. Let's see, there range drop, IEEE floats, and what, and if I had range, what do you mean with IEEE floats exactly? You mean those floats that, I mean, ironically, not sure what you mean though, but I mean, ironically, this is certainly one thing that could also be removed. I mean, it's only we talk here like maybe less than 1% silicon area, but all legacy features are counting. And also, as similar on our FPGA design series, the more logic you add, the slower your total clock will be, especially with some special case here and some logic signal there of legacy, whatever, real mode and segment handling and yada yada yada, all this amazing, or yeah, right, the bloody at least 32-bit protected mode handling is anyway complete bonkers. But of course, all the latest Intel and AMD silicon still support the 386 annoyingly complex stack-based and 80-bit precision, extended precision floating point unit, right? Not that you would use that in 64-bit programming, but if you boot DOS and run old-fashioned 32-bit software, even like decade-old Linux desktop or stuff like we do here on this channel, you have your old-fashioned FPU. It's of course not much. I mean, it's of course a grain of salt there in less than 1% of, but each stuff counts, right? I mean, eventually maybe that would be an idea to save a little bit of complexity, and maybe, I mean, 200 megahertz more. I mean, I would take the 200 megahertz more of not being able to boot DOS and Windows 3.11 or something, or Windows 95, or fun stuff, not fun stuff like that. Anyway, that's it probably for this video, as usual, with some surrounding discussions, 45 minutes, a little bit longer than I expected. Maybe I need to try better to only do stuff 20 minutes, not to prevent new people from actually starting watching these videos. Last comments: save chip space, put hash tables with very fast, accurate unums that don't overflow or null, since processors have a lot of cache now. Just make static 16 length instructions and use extra space for instructions that don't need to be undoings 16, if you mean 16 bits, because bits missing there, length instructions. That's of course RISC-V. I mean, I think, in my opinion, of what I've seen and worked with RISC-V and the compressed RISC-V stuff, looks very promising. We actually have here all ISOs built, and we can, let's compare all the minimal desktop ISOs. That is not a super fair comparison, but of course, so x86 is smaller, so AMD 64, so they should be quite identical, given it's all the same set of source versions. It's the same, mostly this is of course documentation and images, so all the size differences actually for the most part the binary sizes, and they are all built, see up with the previous videos of T2 goodness, just raw vanilla Linux. And yeah, from RISC-V is actually the smallest here, surprisingly, right? Maybe this is using compressed, not sure what this is building, most likely. And yeah, ARM is ARM64 is second. And we have also other builds, but my other builds are not directly comparable because for others, due to Firefox or Rust segmentation faulting, we are not building the same Firefox feature set. But comparing those, this is RISC-V, the smallest, followed by ARM64, x86 legacy, Pentium optimized, and then AMD 64 of how complex and large stuff can be. And this is not even using AVX and stuff, so this is only good old-fashioned second generation Intel, no Kona, AMD, whatever. So basically Athlon 64 plus SSE 3 and without 3D now, so yeah. Anyway, that's it for this video. I hope you learned something. I hope you found some hardware to purchase what you need, otherwise it's certainly rather frustrating playing along at home in this pandemic times without even getting access to the hardware most people wanted or need. I hope you learned something. If you're new to this channel, there is this, share, like and subscribe. Otherwise, thanks for tuning in, and to see you soon for the next videos and live streams to come.